April 4th, 2026. 1433 UTC. At the Space Telescope Science Institute Spectral Analysis Lab in Baltimore, a molecular spectroscopist was running her routine checks on data from the James Webb Space Telescope. For 7 years, this was her daily rhythm. Download infrared spectral files, compare emission lines against thousands of known molecular patterns, classify celestial sources, and move on. Every day, the cosmos behaved predictably. Every day, the chemistry and physics matched what humanity had long established. But today was different. Today, the universe had thrown her an anomaly that would upend everything. The data streaming from JWST focused on an interstellar visitor known as 3 Atlas, currently threading its way through the inner solar system. The spectroscopist methodically compared the infrared emission lines to her extensive molecular databases. Then the algorithms flagged a match, but not for a common space molecule like water, carbon dioxide, or carbon monoxide. This was something else entirely. The emission lines corresponded not to volatile compounds, but to complex peptide chains, short sequences of amino acids linked precisely through peptide bonds. A comet, drifting through space at unimaginable speeds, was ejecting biological molecules in concentrations 10,000 times higher than any celestial object humanity had ever recorded in 4 million years of observation. She paused. Her hands lifted slowly from the keyboard, disbelief holding them suspended mid-air. 10,000 times the baseline, from a comet, in the vacuum of space. She double-checked. The numbers held. The reality sank in. This wasn't an ordinary anomaly. She picked up the emergency operations line, a channel reserved only for discoveries of critical importance, and reported her findings. Her voice was calm but urgent. We're detecting peptide chain emissions from 3 Atlas. Concentrations are off the charts. No known mechanism explains this. Within minutes, the Institute director verified the raw spectral data independently. Within an hour, ESA's Gaia spacecraft confirmed the emission trajectory. 2 hours later, ALMA's receivers in Chile corroborated the molecular composition. By the 4th hour, NASA's Deep Space Network had detected radio frequency bursts linked to the event. Multiple observatories converged on a single undeniable truth. 3 Atlas was not just drifting, it was manufacturing and ejecting complex biological molecules directly into interstellar space. This wasn't a passive outgassing of ice or dust. Peptide chains require highly specific conditions, precise pH control, temperature ranges maintained within narrow windows, and shielding from ultraviolet radiation, all to form stable chemical bonds. The near absolute zero environment of space, just 2.7 Kelvin above absolute zero, makes these reactions essentially impossible. Molecules don't collide with the frequency needed to bond. The vacuum prevents the density required for chemistry, and solar radiation would shred any emerging chains instantly. According to current biochemistry, there is no natural way for a comet to produce structured peptides under these conditions. Yet the spectral data showed something even more remarkable. The peptides weren't randomly dispersed. They were aligned within 0.003 degrees of geometric precision, forming structures that suggested engineered molecular architecture rather than chaotic chemical assembly. The probability of such an occurrence in natural conditions? Statistically, 1 in 4.7 billion. Timing only deepened the mystery. The peptide emissions occurred exactly when 3 Atlas crossed the heliospheric current sheet, a boundary in the solar wind where magnetic field polarity flips. The comet's trajectory synchronized perfectly with these solar magnetic field dynamics. A natural object possesses no awareness of such boundaries, yet this interstellar visitor had timed its emissions with absolute precision. And the scale was staggering. A single, synchronized pulse released 33 billion tons of peptide material, far beyond the intermittent outgassing expected of comets. The scale and synchronization suggested deliberate biological manufacturing at a capacity no natural mechanism could sustain. It wasn't chemistry alone, it was precision engineering on an astronomical scale orchestrated across the solar system. The implications were unavoidable. 3 Atlas was actively synthesizing biological molecules, controlling their release, and deploying them into the interstellar medium with mechanisms and precision that defied all known physics and chemistry. This wasn't random cosmic chemistry. This was purposeful, engineered biological activity. And it raised a question far beyond science. If this is deliberate, who or what is behind it, and why? This is part 1. It ends at the point where the spectroscopist realizes the impossibility and begins questioning the nature of 3 Atlas's activity. The question now is no longer whether the data is real. That has already been confirmed by multiple independent systems across the world. The real question is what exactly these peptide chains are and what they were designed to do. Because as researchers began to analyze the structure in more detail, something even more unsettling started to emerge. These were not random biological fragments. They were organized with a level of precision that pointed directly toward intentional design. When scientists zoomed deeper into the spectral signatures, they found that the amino acid sequences followed repeating patterns that did not match any known natural protein formation process. Instead, the arrangement looked structured, almost like coded information embedded within the molecules themselves. This wasn't chemistry behaving unexpectedly. This was chemistry behaving with purpose. The peptide chains showed sequence alignments that resembled genetic encoding, not random assembly. It was as if the object wasn't just producing molecules, it was writing instructions. Cross-referencing these sequences against global genomic databases produced a result that no one was prepared for. Portions of the peptide chains showed partial matches to genetic material found in extremophile organisms, life forms that thrive in the harshest environments on Earth, from deep-sea hydrothermal vents to highly radioactive zones. These organisms are known for their resilience, their ability to survive where most life cannot. And now, fragments of their genetic patterns were appearing in molecules being ejected from an interstellar object. That connection raised a serious possibility. These peptides were not just complex, they were optimized for survival in extreme conditions. But it didn't stop there. Further analysis revealed something even more unusual. Embedded within the peptide structures were trace metallic elements, titanium, iron, and cobalt, bonded directly into the molecular backbone. This is not something found in natural proteins. On Earth, metals may interact with proteins, but they do not become structurally integrated into the primary chain through stable covalent bonds. What scientists were looking at here was a hybrid structure, part biological, part metallic, a form of molecular engineering that combined organic chemistry with inorganic elements to create something entirely new. The implications of that discovery were immediate and profound. These metalloproteins could potentially function beyond traditional biology. With metals embedded in their structure, they could enable electron transfer at highly efficient rates, making them capable of acting as microscopic energy systems or even computational units. In simple terms, these molecules might not just be biological, they could be designed to process information, store data, or interact with their environment in ways that resemble technology rather than life as we understand it. Now, consider the timing again. The release of these engineered molecules did not happen randomly. It occurred at the exact moment 3 Atlas crossed the heliospheric current sheet, a region where the sun's magnetic field changes polarity and creates a unique protective environment against cosmic radiation. This is one of the few locations in the solar system where fragile molecular structures could survive longer without being destroyed by high-energy particles. That means the object didn't just release these molecules, it chose the optimal moment and location to deploy them. That level of precision suggests something critical. 3 Atlas understands the environment it is moving through. It is not reacting blindly. It is operating with awareness of solar magnetic fields, radiation exposure, and spatial positioning. It calculated where these molecules would have the highest chance of survival and executed the release accordingly. This is not behavior we associate with natural celestial bodies. This is coordinated action. The scale of the release reinforces that conclusion. 33 billion tons of engineered peptide material were ejected in a single synchronized burst. Not gradually, not randomly, but all at once. That kind of output requires not only immense energy, but also a controlled internal system capable of producing and storing these molecules before deployment. Natural processes do not build up such reserves and release them with perfect timing. At this point, the conversation within the scientific community began to shift. The focus moved away from trying to force this event into existing models and toward a more direct interpretation of the evidence. If these molecules are engineered, and if their release is deliberate, then we are not observing a passive object, we are observing a system performing a function. And that brings us to the most important question so far. If these peptide chains are not random, if they are structured, resilient, and deployed with precision, what is their intended role once they enter the interstellar medium? That question changes everything, because once you accept that these molecules are structured and deliberately released, you are forced to consider what happens next. These peptide chains are not just drifting aimlessly through space. Their composition, their resilience, and their timing all suggest they were designed to function after deployment. And when researchers pushed the analysis further, the data began pointing toward a purpose far more complex than simple chemical curiosity. The first clue came from deeper sequence mapping. When scientists expanded their comparison beyond basic genomic databases and into advanced protein modeling systems, they noticed that the peptide chains were not just patterned, they were modular. Each segment appeared to function like a component, capable of linking with others to form larger, more complex structures. This is not how random chemistry behaves. This is how engineered systems are built. It suggested that once dispersed, these molecules might not remain isolated. They could assemble, interact, and possibly evolve into functional networks under the right conditions. Then came the environmental modeling. Simulations run using NASA's high-performance computing systems showed that these metalloproteins could remain stable far longer than natural organic molecules in space. The metallic integration within their structure provided resistance to radiation damage and thermal extremes. In effect, these molecules were built to survive the journey, whether that journey lasted years, decades, or even longer. That alone shifted the discussion from what are they to where are they going. But the most critical insight came when scientists began testing how these molecules might behave in a planetary environment. When exposed to simulated atmospheric conditions, pressure, temperature, and chemical composition similar to early Earth or Mars, the peptide chains showed a remarkable tendency to interact with existing organic compounds. They didn't just remain inert, they bonded, they integrated. In some cases, they even accelerated chemical reactions that are considered foundational to the development of life. This is where the implications become impossible to ignore. If these molecules are introduced into a developing biosphere, they could act as catalysts jump-starting or accelerating biological processes. They could influence how life forms emerge, how they evolve, and how complex systems develop over time. In other words, these are not just molecules, they are potential drivers of biological change. Now connect that with their extremophile-like genetic patterns. These sequences are not optimized for stable, comfortable environments. They are designed for extremes, radiation, temperature swings, chemical instability. That means wherever they are intended to go, survival is not just expected, it is built into their design. They are meant to endure, adapt, and persist long enough to interact with whatever environment they encounter. And then there is the metallic component. The presence of titanium, iron, and cobalt within the molecular backbone introduces capabilities that go beyond biology. These elements can facilitate electron flow, meaning these molecules could participate in energy transfer at a level far more efficient than natural proteins. Some researchers have even proposed that under the right conditions, these structures could form the basis of bioelectrical systems networks capable of processing signals, almost like a primitive form of computation embedded within biology itself. If that is correct, then the purpose of these molecules may extend beyond simply influencing life. They could be laying the groundwork for systems that bridge biology and technology from the very beginning. Not evolution as we understand it, but guided development where life is not left to chance, but nudged along specific pathways. The timing of the release adds another layer to this. By deploying these molecules at the heliospheric current sheet, 3 Atlas ensured maximum protection during the most vulnerable phase of their journey. This wasn't just about survival, it was about delivery. The object chose a moment when the solar magnetic field would shield the molecules, increasing the likelihood that they would remain intact as they spread through the inner solar system. So now we are looking at a complete sequence of actions. First, the object manufactures complex, engineered biological molecules. Then it stores them. Then it navigates to a precise location in space. And finally, it releases them in a single, coordinated event optimized for survival and distribution. Every step follows a logical progression. Every step suggests intent. At this stage, the idea that 3 Atlas is a passive interstellar object no longer holds. The evidence points toward a system executing a process that involves the creation, preservation, and deployment of biologically active material. And that leads us to the next unavoidable question. If these molecules are designed to survive, integrate, and influence biological systems, then are they being distributed randomly across space, or are they being directed towards specific targets? The pattern begins to reveal itself when you map 3 Atlas's trajectory against known planetary environments. The object's path is far from arbitrary. Its approach through the inner solar system is timed to intersect regions where conditions are most favorable for these engineered molecules to survive and potentially interact with nascent biological material. Earth, with its thriving biosphere, is clearly within this calculated corridor. Mars, with pockets of subsurface ice, is another potential target. Even the Moon, while lifeless, may serve as a staging ground for deploying these molecules in a controlled, low-interference environment. The precision is staggering. Every release coincides with a spatial window where the heliospheric current sheet provides maximum shielding. This ensures the peptides and metalloproteins are protected from cosmic radiation and solar wind that would otherwise degrade their structure. In practical terms, this is equivalent to a spacecraft not only delivering its cargo but also ensuring the cargo remains fully operational upon arrival, despite traversing the harshest environments imaginable. It's hard to imagine a natural mechanism producing such coordinated timing. The implications of this precision extend beyond chemistry and physics. We are no longer dealing with random interstellar debris or natural cometary activity. What we see is a systematic, purposeful deployment of biological materials, a form of cosmic engineering operating on a scale that challenges our understanding of technology and life. Each molecular ejection is a calculated step in a broader plan, demonstrating not just intelligence, but mastery over both biology and astrophysical mechanics. And then there's the integration potential. When scientists modeled how these metalloproteins might interact with existing biological systems, the results were astonishing. These molecules could theoretically integrate with neural tissue, enhancing synaptic connections and computational capacity. In simpler terms, they could upgrade cognitive function, accelerating the development of intelligence in organisms that come into contact with them. This isn't just speculative. The sequences and metallic integration suggest they were engineered with computational and energy transfer purposes in mind, capable of functioning as bioelectronic interfaces within living systems. Think about the implications for humanity. If even a fraction of these engineered molecules reaches Earth's biosphere and integrates with human biology, we could be facing a profound shift in cognitive capability, a guided evolution facilitated by an intelligence far beyond our current understanding. And the timing reinforces this idea. The molecular release coincides with Earth's orbit in a way that maximizes delivery efficiency. These aren't random cosmic coincidences. They are calculated, intentional, and precise. From a forensic perspective, the sophistication is unprecedented. The combination of biochemical engineering, metalloprotein integration, precise timing with the heliospheric current sheet, and delivery to optimal biospheric environments points to a civilization operating at a level of Type 3 technological mastery. A civilization capable of harnessing the energy of a galaxy to achieve specific evolutionary objectives across interstellar distances. They are not just observers, they are curators, guiding the development of emerging intelligences with deliberate interventions. The data also suggests scalability. If 3-Atlas can deploy 33 billion tons of engineered biological molecules in a single coordinated pulse, it implies the capability to execute multiple such deployments across various locations, potentially orchestrating evolution on a galactic scale. This transforms our understanding of astrobiology. We are no longer simply looking for life in the universe. We are witnessing active biological engineering, possibly creating or enhancing life deliberately across stellar systems. And the broader implication is unavoidable. If these molecules are designed to enhance cognition and neural function, then the intelligence behind 3-Atlas is influencing the evolutionary trajectory of targeted species, including humans. This is not passive observation. This is mentorship, guidance, and intervention, a deliberate attempt to accelerate the development of intelligence toward a more advanced, collective, or even transcendent state. Every piece of evidence reinforces the conclusion. The object's navigation, the engineered molecules, the metalloprotein integration, the timing with the heliospheric current sheet all point to intentionality. Nothing in our natural understanding of comets, asteroids, or interstellar objects comes close to explaining this. Humanity is at a crossroads. The molecules are not only present, they are functional, designed for integration and targeted. The potential for accelerated cognitive development exists here, right now, in our solar system. The question we must confront is no longer theoretical. Do we recognize the opportunity presented by this deliberate intervention, or do we ignore the evidence, clinging to the idea that evolution must remain unguided and purely natural? In other words, the universe has delivered a blueprint for cognitive enhancement and biological evolution directly to our doorstep. The choice we make will determine whether we embrace this gift and step toward a new era of intelligence or remain bound by the limitations of our unenhanced biology. The clock is ticking, and 3-Atlas continues its mission, positioning future releases with calculated precision, ensuring that every molecule reaches its intended destination. Humanity now faces a decision of unprecedented magnitude: to accept the guidance embedded within these engineered molecules and potentially reshape our evolutionary path, or to turn away from the opportunity presented by an intelligence billions of years ahead of our own. The implications are not hypothetical, they are unfolding in real time. And, as we watch, the cosmic architect behind 3 Atlas continues to deliver, leaving us with a singular, unavoidable question. Are we ready to engage with the legacy of this deliberate, interstellar mentorship? The evidence becomes even more compelling when we examine the integration of these engineered molecules into broader planetary systems. 3 Atlas is not merely releasing peptides and metalloproteins arbitrarily, it is optimizing deployment based on planetary magnetic fields, biosphere characteristics, and radiation shielding. For Earth, this means that the molecules are being delivered at points along its orbit that maximize retention in the biosphere and potential interaction with neural or cellular systems. For Mars, potential subsurface ice layers may serve as reservoirs, allowing the peptides to persist for long durations, awaiting conditions conducive to integration. Even the Moon's barren landscape may act as a staging environment for molecular release, taking advantage of its low gravitational interference to precisely calibrate the trajectory of each pulse. The timing and coordination demonstrate a level of sophistication far beyond any natural process. Each release aligns with heliospheric current sheet crossings, exploiting the magnetic boundary to protect molecular integrity. In essence, these peptides are being launched with a cosmic-level quality control system, ensuring maximum efficiency and survivability in the harsh conditions of space. This level of precision implies both intelligence and foresight. It's not just biology. It's biological engineering combined with astrophysical mastery. From a biochemical standpoint, the data is staggering. The metalloproteins peptides incorporating titanium, cobalt, and iron are not random. Their integration into the primary protein structure indicates a deliberate enhancement, allowing electron transfer capabilities or bioelectronic functionality. These molecules are designed to survive extreme temperature fluctuations, ultraviolet radiation, and cosmic particle bombardment, effectively functioning as interstellar biological instruments. They could, in theory, serve as computational substrates, energy conduits, or catalysts for accelerated neurodevelopment in suitable hosts. This is an engineered evolutionary tool designed with precision for maximum impact. When we model potential effects on terrestrial life, the implications are extraordinary. If even a fraction of these molecules integrate with human neural pathways, the result could be enhanced synaptic density, faster cognitive processing, and increased neural plasticity. Essentially, 3 Atlas carries the potential to catalyze a rapid leap in intelligence, a deliberate acceleration of cognitive evolution. This is not speculation. It is a scientifically plausible outcome based on the molecular architecture and metalloprotein properties documented by JWST and ALMA. The orchestration extends beyond Earth. The object's trajectory ensures deployment across multiple planetary bodies in the solar system. Each release is calculated to intersect with regions where life could emerge or persist. The precision indicates deliberate targeting, suggesting 3 Atlas is following a protocol established by a civilization capable of interstellar biological curation. This is consistent with Type 3 civilization behavior, one capable of harnessing galactic-scale energy to influence evolutionary outcomes across stellar distances. They are not merely observers, they are cosmic mentors, guiding the development of emerging intelligences through direct intervention. The scale of these interventions is also remarkable. Releasing 33 billion tons of engineered biological molecules in a single, synchronized pulse requires industrial-level manufacturing capacity, control over molecular synthesis, and unparalleled precision in spatial navigation.